So Ella and Haley, let's talk about this. We have log base 7, 3x minus 2 equals 2. Now, just as a reminder, last time we had something like an exponent here, base of an exponent, we moved it over and it became a base of a log. So when we made the base of the exponent, it became a base of the log. So what do you think the base of the log will become? Anyone wants to give a guess?
Like, does it become 7 log? Like, does it switch like that or no?
It is a 7
or is it
log.
2?
Now it's going
Like,
to
is it
become
2 log to 7 exponent, or am I wrong?
No, it's not that. Because it's the base of a
Okay,
log,
then I don't know.
when you transfer it over, it's going to become the base of an exponent. So when it's a base of a log, it'll become the base of an exponent. So here on the left is 3x minus 2. Here on the right is 7 to the second power. So the 7 kind of like slips underneath the number and becomes the base of an exponent. So it's base 7.
That's so weird.
That's how it is, though. It's just these are opposites. Like I said, the base of an exponent is opposite of the base of the log. Okay. From here, we have 7 squared. We actually know what 7 squared is, and we can find it if we have a calculator. So that's 49. So 3x minus 2 equals 49. I'm going to do plus 2 on both sides. 3x is going to give me 51. And I'm going to divide it by 3 on both sides. X is going to be 17. So all I did is a little bit of algebra after I moved over to log exponent. That is my goal, to get rid of that log so then I could do some algebra. Okay. You know what? Actually, let me do this. Get away for a second. Let's do a different example to emphasize this kind of concept. Log, not to be exponent, sorry. Base 3 of 4x plus 2 plus 1 plus 2 equals 2. So let's do that one as an example. Let me hide this guy for a minute. Go away. Whatever. So log base 3, 4x plus 2 equals 2. So Haley, I have the base of the log. When I move it over to the other side, what is it going to become?
3 squared.
Good. It becomes the base of the exponent. So it's going to become 3 squared. So 4x plus 2 equals 3 to the second power. That 3 came from the log. So it became the base of the log. Well, 3 squared is 9. 4x plus 2 equals 9. Subtract 2 on both sides. 4x equals 7. Divided by 4 on both sides. X equals 7 over 4. If you had a calculator, 1.75. Either answer is correct. So again, the actual final steps are easy. That's just algebra 1 stuff. You need to know the concepts of logs and how they have the relationship with exponents. So I'll leave that there so you can finish copying that down. I'm going to put a different one here.
Wait, Mr. Chabal, can you scroll back up for a second? Because I was still on the last one.
Sure.
Thanks.
No problem. Let's do 4 ln x plus you know what? I'm going to do 2x in here. I'll put 2x in there.
Wait, Mr. Toll, I have a question on the last one.
Sure. On number 2?
Yeah, number 1.
Oh, okay.
How did you get 7 squared? Like, I don't understand how log 7 went to.
So this 7, the base of the log 7, when moved over, becomes the base of the exponent 7.
So what happened to the log?
Oh, I think we talked about this in the beginning weeks. I just don't mention it because knowing this fact doesn't really matter. But when you have 7 to the log base 7, so you have a in the exponent, the base here, they cancel out. So what you're technically doing is that you're putting I'll erase this arrow for a second. What you're technically doing is you're putting a base 7 underneath both of these things. Now, if I put a base 7 on the left, that crosses the log out. How I always describe it to you guys is just I move the base of the 7 over here. But technically, I'm canceling it out, okay? Very similar to this kind of concept, Alyssa, just to finish it off. Let's say 3x equals 12. I could say I'm dividing 3 on both sides, and this crosses out. Same here. I'm putting a 7 underneath, and it crosses out. Okay. Okay. Let's talk about the third one, number 3 here. In number 3, we have 4 ln 2x plus 3 equals 23. The 2x is in the ln. 925. All right. Now first, before I could do that trick of slipping something underneath, or IFKA, bring the base of the log to the base of the other side, what we need to do is get the logs by itself. We need one single log by itself. So in order to do that, we're going to have to get it isolated. So it's kind of like 4 variable plus 3. So all I'm doing is the algebra to get ln by itself, which would require me doing -3 and -3. So 4 ln 2x equals 20.
Wait, so 4ln and 2x is like together?
It's 4 times ln 2x, yeah.
Oh,
Which
okay.
you could just write next to each other. Then it's 4 times ln. Now somebody could probably mention, Mr. Tobel, can you make it an exponent? You could make 4 an exponent to the thing and do that, but that's going to be more work than dividing by 4. Because ask yourself, what's easier, dividing by 4 or raising something to the 4th power? Definitely easier to divide by 4. So if we have that opportunity, let's do it that way. So divided by 4, ln of 2x equals 5. Now, Ella, do you remember what ln equals or what type of log it is? Log E?
Yeah, sure.
Yeah, good. Log E. So ln is the same as log E. No, when you don't see a number, like a plain log, that's log 10, okay? Just to make sure that's different. So this is log E. So when I move the ln to both sides, which you do in red, this is a different thing. When I move the ln to both sides, or the other side, what occurs is I'm going to get 2x, which is left over after I cross out the ln, equals base e to the 5th power. E
Can you
to the
explain that again, Mr. Tobo? That part with like the ln 2x equals 5, bringing it up. I just got confused.
All right, one more time. ln is the same as log base e. You need to know that when you see the letters ln, that's the same as log base e. And when you see just a plain log with no number on it, you assume it's a 10. So if it's just plain log like this, you'd assume it's the value of 10. Now I'm going to clear this though. You have written this before, Mariah. All right, here we're going to do divided by 2, divided by 2. We're going to treat e kind of like a variable where we're not going to do the math, but e does have a decimal number, kind of like pi. Sometimes you don't do the pi. You just leave it as pi. We'll just leave it as e. So x equals e to the 5th power divided by 2, because I divided by 2 on both sides, and that's my answer.
I got that. So you're saying whatever like the number is on the outside, the e is going to be the exponent to it?
Whatever number is going to be on the bottom of the log, not on the outside necessarily, but the bottom of the log.
But you put the exponent 5 for e.
Oh, that's what you mean? Yeah, yeah. So the
That's what I was
number on the,
asking. Yeah, that part.
yeah, the number on the other side will be the exponent. Good question. I'm sorry.
Okay, perfect.
All right. Number 4 literally combines
Wait, Mr.
every
Joel?
skill. Yeah, what's up, Alyssa?
I feel like we're not gonna like know when to use an E and when to not use an E. Like it's so random. Like some problems have, some problems don't.
It's not random. The reason you use E is because you have the box ln. That's when you use E, because you have the letters ln. If you have log base 7, you use 7. If you have log base 3, you use 3. So it's just based on what they give you. It's definitely not random. You need to know, this is definitely something you need to remember. ln equals log base e. You got to commit that to remembering. E being like the small little e, like a little e right here. Okay, that's something important. Ella, you got to speak up. I feel like you're whispering. Go ahead.
For number 4, do we like combine or like multiply log?
Perfect. So Ella said it. We have 2 logs here, and we can't move it over unless we have 1 log. So we're going to combine them. Haley, you finish it off. Because it's a plus sign, what kind of combination will occur?
Do you just add the 2 6s?
No, you don't. You add the 2 logs, which means the stuff on the inside. But you're not adding it. When you have a plus sign in between, what do you actually do?
Multiply.
Good, multiply. Thank you, Ella, for the pickup. So we're going to multiply this. So it's going to be log base 6. The base will stay the same. Don't change the base. 3x, x minus 1. That equals 3. So when you condense it, you're multiplying it. We went over those skills previously. Also, side note, technically you can only do this if they have the same base log. I'm never going to give you a different base log, but I just want to point that out. They have to have the same base log. So 3x and x minus 1, I'm just going to distribute that. So I got log base 6, 3x squared minus 3x. Now, Eliana, are you there?
Wait, Mr. Tawal?
Yeah. This.
I have a question.
This.
So you just, I thought you were supposed to cancel out one of the log sixes because you have two.
We technically cancel it out by combining them. You can't cancel them out, like do the bring it over, unless there's exactly one of them. So we have to combine it into one big log. And I just want to ask you, Ayana, I want to get rid of this log 6, as you mentioned. So what do I have to do to the other side? Well, I'm going to have to put the little 6 underneath it. So it's going to be 3x squared minus 3x equals the 6 of a base of an exponent to the third power. So the 6 on here becomes the 6 over here. 6 to the third power is 6, 36, 216, 3x squared minus 3x. We want to set this equal to 0. So I'm going to subtract 216 on both sides. Now, I'll be very honest. This will cause us to do a quadratic, if you remember quadratics from the past. Now, on your test, I will not give you quadratic formulas. So this example is above the level I would give you. You would not be forced to do a quadratic. So you would do the math here, what multiplies to negative 21, you bring 3 over, do all that math if you want to finish it. I'm telling you, I will not give you a problem like this, so I don't want to finish it. So we'll just box it as is. I didn't check this example, or I didn't expect this example to cause that. So you could stop right here. But if it was something doable, you would continue on just like the previous problems. Okay. All right. We have one more page of notes, and then we're finished for the test information. Does anyone have questions on this page? I'll try to zoom out a bit so you could probably see. Well, that's pretty zoomed out. I don't know if you can read anything. If anyone has any questions, you could ask. All right. Let's go to the last and final page. So we're going to solve this one. We'll call this exponent basis. Exponent base on both sides. And you know what? Do not write number 1. That's a lot harder than I want you to do. Let's do a very easy one first. So let me change the question here. This question will be 3 to the x power equals 9 to the 12th power. Yeah. I'm going to change this one too. These are too difficult for this. Or this is not what I want to teach you. So first write down the first question. Okay. So 3 to the x power equals 9 to the 12th power. Now, what would be nice if we had the same situation as we had logs last time? And just a reminder, what does that mean? In previous questions, when the log was the same thing on both sides, so like here, the log was the same thing on both sides, what we could do is cross it out. Now, if the exponents were the same on both sides, the base of the exponents, we would be able to cross them out. But we have a problem. These are not the same. So what we're going to try to do is rewrite one of them to be the same as the other. And the
So
wonderful
you're
question.
doing 3 times 3?
Well, oh, look at that. Good, good. So we have a 3 here and we have a 9 here. Now, I can't make my 3 bigger because that'd be cheating. But is there a way I could rewrite 9 to make it look like a 3? I could rewrite 9 as 3, so 9 equals 3 to the second power, or 3 times 3, as Mariah mentioned. So 3x will be on the left, normal. But on the right side, I'm changing my 9 into 3 squared.
Wait, why do you do that? That's so weird.
I'll show you why we do that. We'll get to that point. But this 12 right here is still round, so just rewrite that 12. So 3 to the x equals 3 to the 12, or 3 to the 2 power to the 12 power.
Oh, because now it's just saying 9, 12. Like it's writing out the same thing. Okay.
Yeah. Now, does anyone remember, what do you do when you have an exponent to an exponent? What do you do to those exponents?
Multiply them.
Good, Ella. You multiply them. So 2 times 12, what you get?
24.
Good. 3x equals 3 to the 24. Now, this is why we churn it into a 3. Since the base of the 3's are exactly the same, because they're exactly the same, I can cross them both out. I can
Why are you
cross
crossing
them.
them out?
I'm crossing them out because look, if it's 3 to the x power and 3 to the 24 power, what would x have to be? We could use a little mental math. What does x have to be?
X equals 24.
X
Given the
equals
answer.
24. So what it means is because their base is the same, we could cross it out and do it. Now this one's very straightforward because it's just x equals 24. We'll see in the next one, you'll do a little bit of math or algebra with it, okay? So in this question, your goal is to change one of the bases to match the other. Very important though, you're usually going from big to small. You want to go from big to small. Let's talk about number 2. These guys we're not going to use, so I'm just going to delete them. That's a little too difficult for us. Or we could do it, but I don't want to. I already hear people having a hard time, so I don't want to make it too hard. So we'll do easier problems. Okay. So number 2. 2 to the 4x problem, 2 to the 4x exponent equals 8 to the x plus 1 exponent. So my bases are 2 and 8. Alyssa, if you're there, which one would be easier to make? Make it 8 smaller to the 2 or make the 2 bigger to the 8?
Make the 2 bigger.
The problem with making the 2 bigger, that's fine because instinctively people say, well, I know 2 times 2 would be smarter. But to make the 2 bigger, you would have to start using fraction exponents. You will have to make this like
Oh,
1 to the
no.
third. So yeah, nobody really wants that. So you usually want to go from bigger to smaller. So Alyssa,
Wait, so you can't
Go
make
ahead.
two
Oh.
bigger, you're saying?
You could make 2 bigger, but you'll deal with fractions, and I know nobody wants to deal with that. So making bigger to smaller will give you whole numbers, which is a lot easier. Alyssa, what does 8 equal to when you were talking about like a power of 2? Like 2 to the power of what equals 8?
Squared? 2, no.
2 squared would be 4, so no.
2 to the 4th power?
Well, 2 to the 4th power would be 16. So probably somewhere in between.
2 to the 3rd power?
2 to the 3rd power. 2 to the 3rd power would be 8. So what I'm going to do with that information is I'm changing my 8 into 2 to the 3rd power. So 2 to the 4x, normal. This 8 becomes 2 to the 3rd power. But you can't forget that old exponent that was there already or originally. So x plus 1. Okay. Now, this 3rd power over here and this x plus 1 power over here, exponent to exponent, you're going to multiply it. So I'll just do a kind of a little distribution here. So this is going to be 2 to the 4x equals 2 to the 3x plus 3. All I did is distribute that power to this power. Or you could do it backwards, but usually you do 1 to 2 things versus 2 to 1 things. Same difference though.
Won't it just be 6x?
6x? Why 6x?
Like as the exponent, because 3x plus 3 is 6x.
No, because this is 3x and this is just a normal 3. So you can't combine the terms like that.
So now do you
Oh,
cross out the 2s?
Perfect, Alyssa. Now we're going to cross out the 2s, the base 2s. And then we simply have, I guess I'll do it in green, 4x equals 3x plus 3. A little bit of algebra 1, maybe a little pre-algebra if you want to think about it. Minus 3x minus 3x. Your final answer, x equals 3. I would give you the last one as an exit ticket, but we have so little time. I don't want anyone to miss out on the help for this. So I'm just going to do the steps. So then I'll post this notes later and post a recording later too.
thank you so much, Mr. Tobal. Have a good one.
Well, I'm still doing this problem. Or she just left. All right. So I'll do this problem. We have 64 and 2. So I need to figure out 2 to what power equals 64. Just to make it quicker, that's going to be 2 to the 8th power. Wait a second. 2, 4, 8, 16. Another 6. No. 32, 48. My bad. 2 to the 6th power. My fault.
Wait, Mr. Tall, do you think it's okay if we try it by ourselves first?
You know what? I'll give you that information. Try by yourself. If you want to send me the answer, that's fine. So I'll give it like a minute. I just don't want you to, I don't want to carry you too late. So it'll be a fraction, and that's okay. / decimal. Yeah. You could just leave it as a fraction. This answer will, yes, definitely be a fraction. Let me bring that in. 2. Okay. Anyone wants to give a shot at giving me the answer?
X equals 2. Oh, wait, not
Uh,
2. 3 over 4. 4 over
Uh,
3.
2 over 3, because you're going to cross these out. And you're going to have 3x minus 2 equals 6x minus 3x on both sides. Negative 2 equals 3x, then divided by 3. So negative 2 over 3 equals x.
Wait, why'd you keep the X with the 6?
Oh, just like here, Alyssa, when you do the new variable or the new base of the exponent, do it in blue, you have to multiply the original with it. So it has to be 6 times x. So that would be 6x. Or over here, we did 3 times 3x plus 1. So that's 3x plus 3. So you got to multiply them. Or otherwise, or I guess you wouldn't run out of the x's, but in a previous problem like this one, you would not have an x on the right side. You have 2 times 12, which should be 24. You have to multiply those things. So don't let that disappear.
Mr. Tobal, class ended 2 minutes ago.
I know. So type here for your attendance.
Okay.
A couple people are missing, so they'll get emails about that later. So type here so you don't get an email yourself. And have a wonderful day, guys.
Thank you.
No problem.
Thank you, Mr. Tobal.
No problem.
Thanks.
Peace.